So before we get too far into logarithms, let's take a quick review of our exponent rules. And here I have 10 cubed. And I want to remember that this is 10 times 10 times 10, which equals 1,000. Okay? So anytime you see the number 1,000, you should be able to just quickly and easily convert that, sort of like this, and make sure you recognize that. Once again, here I have 8 to the power of 4. That's going to be 8 times 8 times 8 times 8. Put that in my calculator. I'm getting 4,096. 4,096. So if you see the number 4,096, you should be able to go, oh, that's 8 to the power of 4. 2 to the 7. Once again, we have a whole bunch of 2s, 4, 5, 6, 7 2s. And when you have 7 2s, you multiply those together, you have the number 128. Okay, so 128 is 2 to the 7. What about 10 to the power of negative 6? Well, that's the same as saying 1 over 10 to the power of positive 6. And that's the same as saying 1 over 10 times 10 times 10, 6 times. 1, 2, 3, 4, 5, 6. Okay? So you could take that, and once again, we're dividing by zeros. 1, 2, 3, 4, 5. Oh, one spot. One too many zeros there. Go. Double check. 1, 2, 3, 4, 5, 6. So we need to be able to recognize that when we have these numbers, that we can convert them from exponents into some real numbers. Once again, so if I had 10 to the negative 2, you should be able to look at that and say, oh, that's 0.01. Likewise, if I gave you the number 0.25, you should recognize that that is a quarter. And a quarter is the same thing as 1 over 2 squared. So this is 2 to the power of negative 2. Okay, so we need to be able to make that connection from numbers into exponents. One last thing before I move on is, can you have a number, let's say 10 to the power of 2.5? And I'll let you look at your calculator and do that. But remember your radical rules. That's the same thing as saying 10 squared times the square root of 10. It is possible. Keep that in mind.